Hello everyone, this is Balu. Welcome to my channel CLK. In this video, I am going to discuss about a problem which is based on design of singly reinforced section. And you can see the question here and you can read the question clearly. Here a M20 grade concrete beam of rectangular cross section which is having 250 mm width and 400 mm effective depth is reinforced with Fe415 grade steel bars, that is HYSD bars, high strength deformed bars. It is to be designed to support a limit state of collapse bending moment of 100 kilonewton meter. Design the reinforcement. We have to design the reinforcement. This is just a small sample problem I took in the initial stage, and after that I am going to discuss some difficult problems also. In the upcoming classes, I am going to discuss about other structures like slabs, also retaining walls, water tanks, and all other structures design also I am going to discuss. So please subscribe my channel, and also if you like my way of explanation and my content, click on the bell icon also so that you can get the time to time updates. Now let us start the solution of this problem. Solution. First of all, let us write the given data. It is given that width, that is B, is equal to 250 mm. Next, effective depth D is equal to 400 mm. And also given M20 grade Fe415 grade steel bars, and also given bending moment, that is Mu, is equal to 100 kilonewton meter. Now here we are going to design for singly reinforced section. First of all, we have to check whether it is singly reinforced section or doubly reinforced section. The condition for the singly reinforced section or doubly reinforced section is depends on the limiting moment of resistance and ultimate moment of resistance. That is, I will tell you the clear condition is, if Mu, that is ultimate moment of resistance, is greater than the Mu limit, that is limiting moment of resistance, then it is nothing but doubly reinforced section. And if the condition is reverse, then it is singly reinforced section. So the first step is we have to find out the limiting moment of resistance. Then we have to check whether it is less than ultimate moment of resistance or not. Based on that condition, we have to come to a conclusion that whether it is singly reinforced or doubly reinforced. I took the problem which is based on singly reinforced only. Then it will come automatically singly reinforced section. But anyway, we have to check the whether it is singly reinforced or doubly reinforced. Okay, I am writing the step 1. That is limiting moment of resistance. This Mu limit. Let us calculate the limiting moment of resistance. The actual formula for limiting moment of resistance, which is given as per IS code, is nothing but, here I will write the equation. Mu limit is equal to 0.36 into XU max by D into 1 minus 0.42 into XU max by D into BD square FCK. This is the actual formula which is given in the IS code, and it is available in, we will write the clause for you also, that is page number 96, which is in the IS 456-2000 G 1.1 clause of C. Okay, this is the class, and let's reduce this equation into simple form. That is, here it is given in the question, that is Fe415 grade steel bars. If for Fe415 this XU max by D is nothing but 0.48, and also for Fe500 it is 0.46, and for Fe250, that is mild steel, it is 0.53. These are all the values. If you substitute this XU max by D values in the limiting moment of resistance, you can get the simple equation from that. So let us substitute this XU max by D in 0.48 in this limiting moment of resistance, and you can get the easy equation. I will write the reduced equation here directly. That is mu limit is equal to 0.138 FCK BD square, which is for Fe415 grade, and 0.133 FCK BD square, which is for Fe500 grade of steel, and also 0.148 FCK BD square, which is for Fe250 grade of steel. So these are the reduced equation. Here we have to use this equation, that is nothing but 0.138 FCK BD square, because in the question the grade of the steel is Fe415. Let us find the limiting moment of resistance. Mu limit is equal to 0.138 into FCK is 20 given in the question, and also width is B is nothing but 250, and also effective depth is 400. That is 250 into 400 square. Let us calculate this. 138 into 20 into 250 into 400 square is nothing but 110.4 kilonewton meter. The answer is in Newton mm. I am just converting into kilonewton meter. That is nothing but you have to take 6 digits after that. The point will come 3, 6. That means 110.4. Okay. It is nothing but 110.4 kilonewton meter. Now let us compare this mu limit with mu. Here mu is 100 kilonewton meter. That is mu is less than mu limit. If mu is greater than mu limit, then it is nothing but doubly reinforced section. Here it is less than mu limit, so it is nothing but singly reinforced section. Okay, it is clear that it is a singly reinforced section. Now let us calculate the area of steel which is required in this case. That is step 2. That is area of steel. For that, let us take the ultimate moment of resistance equation. That is mu is equal to 0.87 Fi AST into D into 1 minus AST by BD into Fi by FCK. Okay, let us substitute those values and find out the value of AST here. Here everything is available, that is grade of steel, that is Fi is available, and effective depth value is given in the question, and also width you know, D is you know, FCK is also you know, and mu value is also given in the question, that is 100 kilonewton meter. Let us substitute all these values and find out this AST value. That is 100 into 10 to the power 6. That means 100 kilonewton meter. That's why here 10 to the power 6 came, is equal to 0.87 into 415. That is grade of steel into AST into effective depth. That is nothing but 400 given in the question into 1 minus AST by 250 is the width into 400 into 415 is the grade by FCK is nothing but 20. If you solve this equation, you will get the quadratic equation. You just multiply these numbers and just convert this into quadratic equation. It is just simple equation only. I will write this quadratic equation and I will tell how to solve this quadratic equation in calci also. Don't worry about that. Just you have to learn how to multiply these things in the calci and you will get the how to get this quadratic equation. Just you have to do on yourself. That is 100 into 10 to the power 6 is equal to 144.42 into 10 to the power 3 into AST minus 29.96 AST square. This is the quadratic equation which you are going to get. Now let us solve this quadratic equation using calci. Hundred into 10 to the power 6 here you have to give exact equation in the calci, and giving the exact equation is equal to 144.42 into 10 to the power 3 into, I have to give this AST as unknown, that is nothing but x. Here you can see you have this bracket symbol as x. Alpha, this bracket symbol will give x minus 29.96 into alpha, this bracket symbol, next square. Now we have to solve this equation. For that we have to press shift calc so that you will get asked solve for x. Now click on is equal to. You can get the AST value or whatever the x value in the equation, that is 838.16, which is the mm square. Okay. Now let us write this value here. That is AST is equal to 838.16 mm square. Now we have to convert this AST value into number of bars. Let us assume or let us consider 20 mm bars. Okay, you have to know about the whatever the diameter of the bars available in the market also. I will give some bars list, that is 8, 10, 12, 16, 20, 25, 28, 32, 36. These are the some of the diameters of the bars which are available in the market. Okay, don't take a like irregular diameter. For example, if you take 22 mm bar which is not available in the market, you have to keep in idea like what are the various diameter of the bars which is available in the market. These are the like up to 8 to 36. These are all the diameter of the bars available in the market. Greater than 36, you can Google it and you will get the value. Mostly we use like in between range only for using the construction. And if you use the diameter which is not available in the market also, it is somewhat wrong only. If you do in the exams also, like they will think like you don't have at least idea whatever the diameter of the bar available in the market, and you are designing the section. Okay, now let us like detail the cross section of this singly reinforced section. I will draw the cross section. For example, this is the rectangle section, and these are the bars. Okay, if you divide this AST, that is 838.16, divided by the diameter area of the one single bar, that is pi by 4 into 20 square, you will get approximately 2.7. So we can't provide 2.7 number of bars, so we will take the approximate value which is greater than this fraction, that is nothing but 3 number of bars, 320 bars. Here I drawn 320 mm diameter bars. These are nothing but 320 mm bars. And here the cross section details, that is effective depth is nothing but 400, which is given in the question, 400. And also width of the section is nothing but 250 mm. Okay, this is about the design of the singly reinforced section. Just I take small example and explained you. Hope you are getting whatever I am explaining. And also please comment on my handwriting with the tablet. I am just bought this tablet in the recent times and I am using. It is somewhat difficult only for using. Just comment whether it is like whether you are getting whatever I am writing or not. Also, it will be helpful to improve my handwriting in the upcoming classes also. And also one thing I have to tell. Here I have directly provided the XU max by D value as 0.48, 0.46, 0.453. You can calculate this XU max by D also using the formula, that is XU max by D is equal to 0.0035 by 0.0055 plus 0.87 Fy by ES, where ES is the grade of the steel, that is 200 kN per mm square, which I have already told in the stress strain curve of concrete and steel video. If you don't watch till now, you just watch that video so that you can get the basic points also. This is the formula which is used to calculate the XU max by D. And also this mu, that is ultimate moment of resistance, is taken from the class, that is page 96, same class, that is G 1.1 of B, page 96 it is. Okay, I just forgot to mention this class number from the IS 45620. Okay, this is about this design of singly reinforced section. Hope you got whatever I explained. Okay, I will come with a new problem in the upcoming videos also. And if you have not yet subscribed my channel, please subscribe my channel.